What's going on, everybody? Got another video here for you. This is business calculus, and we're going to look at some graphing. We'll look at increasing, decreasing, critical numbers, critical points, relative extrema, in other words, relative max, relative min. And then it seems from what I gather, a business calculus class, it's this section on graphing, and then they have a whole separate section on graphing again with concavity, finding concave up, concave down. So that will be in another video, the video right after this one. Typically in a calculus class, it's all together, but we'll split it up like they do in the textbook. All right, so let's get started. All right, so increasing and decreasing functions. Let f of x be defined on the interval a to b, and let x1 and x2 be two numbers in the interval. Then f of x is increasing on the interval if f of x2 is greater than f of x1 whenever x2 is greater than x1, and it's decreasing when f of x2 is less than f of x1 whenever x2 is greater than x1. Now, all that I just read you, that may not make a whole lot of sense to you, but I'm going to explain it more when we get to the examples, because I think you'll understand it better when you see the examples. And same thing with most of these procedures. It's easier for you to see when we're doing the examples. So, procedure for using the derivative to determine intervals of increase or decrease for a function f. Find all values of x for which f prime of x is equal to 0 or f prime is not continuous, and mark these numbers on a number line, and that's going to break your number line up into regions. Choose a test number c for each interval a to b. Determine in step 1 and evaluate f prime of c. Then if f prime of c is positive, the function is increasing on that interval, and if f prime of c is negative or less than 0, the function is decreasing on that interval. Now we're gonna revisit this part again when we talk about critical numbers. Okay, so that this is pretty important here. F prime. So basically, to determine where it's increasing and decreasing, we've got to find the derivative, set it equal to 0, and solve for x, or wherever f prime is not continuous. That's the numbers we're looking for. So let's look at this example here, and I'm going to explain this more. Basically, in this next example, we're going to look at both of these. Okay. And it's just easier to understand with the example. So find the intervals of increase and decrease for this function here. All right, so to do that, we need to find the derivative. So that's going to be 6x squared plus 6x minus 12. And then what we do is we set this equal to 0. So we've got 6x squared plus 6x minus 12 equals 0. And of course, we want to make this easy to solve, to factor. So notice we can divide everything by 6. And so we get x squared plus x squared plus x minus 2 equals 0. And then this factors into x plus 2 and x minus 1. So I get x plus 2 equals 0 or x minus 1 equals 0. So x equal negative 2 or x equal 1. And yes, in this class, you're supposed to know how to factor already. All right. So what we do now is we're going to plot these numbers on a number line. Okay, plot the numbers on a number line. All right, so let's look at doing that. So we're going to plot -2, and we're going to plot 1. And that breaks the region up into, it breaks the number line up into 3 regions in this case. And then what we want to do is we want to choose a number from each region. It doesn't matter what numbers you choose as long as they're numbers in each region. All right. So now what we have to do is we have to take the first derivative and evaluate it at each one of these numbers we chose. All right, so look at this. So we can take each one of these numbers here and we can plug them into the derivative here. But, you know, those numbers are kind of big. So, and I mean, I'm not saying it's difficult to evaluate in this because you probably have a calculator. But just take the -3 and plug it into the one that's already factored, into the one that's factored. Okay, you can plug it into this one or this one up here. It doesn't matter. So let's take this and plug it into the one that's factored. So if I plug a -3 in for x, -3 plus 1 is -1. And -3 minus 1 is -4. Okay, I don't really care that it's -1 and it's -4. I don't care about that. The only thing I care about is that this is negative and this is negative. So I've got a negative times a negative, which is a positive. That's all I care about knowing. When I take each one of these numbers and I plug them in, am I getting a negative number or a positive number? And so here I'm getting a positive number. So that means it's increasing. And then I'm going to look at f prime of 0. So if I plug a 0 into here, I've got a +2 times a -1. So a positive times a negative is negative. So that's less than 0. So this is decreasing. And then I've got f prime of 2. So that's going to be 2 plus 2 is 4. 2 minus 1 is 1. I've got a positive times a positive, which is positive. So this is increasing. So this is decreasing on the interval -2 to 1, and it's increasing on the interval -∞ to -2 and 1 to infinity. And that's what they're wanting to know. And basically the way we just worked this is what this right here was telling us to do. See, it's a lot easier to work it than, you know, I mean, it's good that you read through it and understand it and everything, but, you know, but there it is. That's it right there. That's how you find out where it's increasing and decreasing. Okay. Now, be careful, because when you're writing these increasing and decreasing intervals, a lot of times what students will do is like this -∞ to -2. See, from -∞ to -2, it's increasing. Sometimes students will put -∞ and they'll put the -3 instead of the -2. But you got to put the numbers you marked on the number line. All right, let's look at this example. All right, so increasing and decreasing, let's find the derivative. So for this one, well, we got to use the quotient rule to find the derivative. So I've got f prime of x is equal to, so quotient rule is derivative of the numerator times the denominator minus the derivative of the denominator times the numerator. And that's all over the denominator squared. And so this is going to give me f prime of x is equal to 2x squared minus 4x minus x squared over x minus 2 squared. So f prime of x is equal to x squared minus 4x over x minus 2 squared. Okay. So there's our derivative. So now we have to take this x squared minus 4x and set it equal to 0. Well, okay, so what we're doing, to keep this in mind, we're setting the derivative equal to 0. But remember, a fraction is 0 when what? When the numerator is 0. So we only need to set the numerator equal to 0. So that's x times x minus 4 equals 0. So x equals 0, or x minus 4 equals 0. And so we get x equal 4. All right, so we found where the first derivative is equal to 0 at 0 and 4. And then remember, it's also where where f prime, remember up here, find all values of x for which f prime is equal to 0 or f prime is not continuous. So remember, you can't have 0 in the denominator of a fraction. So we know that x minus 2 is equal to 0 when x equal 2. That would make it undefined. So I need to plot all three on the number line. So I've got to plot, let's see, 0, 2, and 4. 0, 2, and 4. And then I need to do what? I need to choose a value from each region. So I'm going to do x equal, let's see, how about -1, x equal 1, x equal 3, and x equal 5. All right. All right, so now I've got f prime of -1. All right, so I've got to figure out where am I gonna plug this in. So let me show you this. This will make it easier on us. X times x minus 4 over x minus 2 squared. Okay, factor that numerator out. You got it factored out anyway. I mean, you factored it out here when you solved it. So just write it factored out. It's easier to plug the stuff in when you do that. I don't even need to worry about plugging anything into the denominator because it doesn't matter what I get in these parentheses here. I'm going to square it so that the denominator is going to always be positive. So now let's plug the -1 in. If I replace this x with a -1 and this x with a -1, that's going to be -1 and -5. A negative times a negative is positive, and a positive divided by a positive is positive, so that's increasing. And then I plug the 1 in. That's a positive, that would be negative, and this is positive. Positive times a negative is a negative. A negative divided by a positive is negative, so that would be negative. Well, I guess I better write this out. F prime of -1 is negative. F of 3, that's going to be positive, negative, right? Positive, negative, and this would be positive down here. So a positive and a negative is negative. Divided by a positive is negative. That's less than 0, so that's decreasing. And then f of 5, that's going to be positive, positive, positive. So that's positive. So this is increasing. All right, so we'll say that this thing is decreasing from what? From 0 to 2 and 2 to 4. And it is increasing from -infinity to 0 and 4 to infinity. And so this would be your answer. All right, that's not too bad so far. I mean, this problem's a little more difficult because you had the fraction, so just a little more to it on taking the derivative. All right, so let's look at this. Critical numbers and critical points. So a number c in the domain of f of x is called a critical number if either f prime of c is equal to 0 or f prime of c does not exist. The corresponding point c f of c on the graph of f of x is called a critical point for f of x. All right. This sounds familiar. What is this? F prime of c is equal to 0 or f prime of c does not exist. Well, look at that. Find all values where f prime of x is equal to 0 or f prime of x is not continuous. That was how we found out if it was increasing or decreasing. But notice how this has something left out. Okay? There's some words in this one. I mean, there's some words that are not in here that are in the ones down here for critical numbers. It says a number c in the domain of f of x. So to find the critical numbers, you're going to set the derivative equal to 0 and solve for x, just like we did before. But the difference is it's not called a critical number if it's not in the domain of the original function. Okay, so basically, in order to determine relative maximum and minimum points, which is what we're fixing to do here in a second, and to graph these things, you want to set the first derivative equal to 0, and you want to know where the first derivative is undefined. Okay, that's how we get our increasing and decreasing and all that good stuff. But for example, in this problem, you see how we got x equals 0, x equals 4, and x equals 2. That's what we plotted on the number line. Okay, so x equals 0 and x equals 4 would be called critical numbers, but x equal 2 would not be a critical number because x equal 2 would make the original function undefined. It's not in the domain of the original function, so it's not called a critical number. Okay, so that's what that's saying. But in order to determine increasing and decreasing, you want to find all these points. It's just that x equal 2 is not a critical number. Okay, so let's look at this. First derivative test for relative extrema. So let c be a critical number for f of x, then the critical point p, which is c f of c, is a relative maximum if f prime of c is positive to the left of c and negative to the right of c, and a relative minimum if f prime of c is negative to the left of c and positive to the right of c. Does that make a whole lot of sense to you? It may not. If you understand that, that's great. If you don't worry about it, because I think you're gonna understand it when we do the example. Okay, and I'll let you know when we're doing this part, or this test, this first derivative test. All right, so let's look at this example. It says find all critical numbers of the function and classify each critical point as a relative maximum, relative minimum, or neither. All right, so here we go. Let's take the derivative. So f prime of x is equal to 8x cubed minus 8x. There's our derivative. And now we take this, set it equal to 0, and we solve. So we get 8x times x squared minus 1 equals 0. So 8x equals 0, or x squared minus 1 equals 0. So x equals 0, or x squared equals 1, x equals plus or minus 1. Remember, square root property, x equals plus or minus the square root of 1. So these are your critical numbers, x equals 0 and x equal plus or minus 1. And the first derivative, it's not undefined anywhere, so we just find where it's equal to 0. All right, so let's so it tells us find all critical numbers and classify each as relative max or mins. All right, so we need to take these and we need to plot these on the number line. And we're going to choose our points. We got to pick, notice we got to pick fractions on this one. All right, so this is where it comes in handy of not actually finding the exact value of f prime when we plug these numbers in, but just determining if it's positive or negative. So I've got f of -2, so plug the -2 in here. So that would be a negative here, right? 8 times -2 is -16. -2 squared is 4. 4 minus 1 is positive, so I got a positive times a negative, which is negative. So that's decreasing. Okay. And then we've got, well, that's f prime of -2. F prime of -1/2. So plug the -1/2 in. That would be negative. 8 times -1/2 is negative. -1/2 squared is 1/4. 1/4 minus 1 is negative. So I've got a negative times a negative is a positive. And so that would be increasing. And then f prime of 1/2, that would be a positive out here, negative here. Positive times a negative is a negative. And so that's decreasing. And then f prime of 2, that's a positive. That's positive. Positive times a positive is positive. So that's increasing. Okay. All right, so we determine where it's increasing and decreasing. And you might be thinking to yourself, well, it's not asking us to find where it's increasing and decreasing, so why did you do that? Well, let me show you. Now, this is where we're coming up here to this first derivative test. So watch this. This is rocket science here. You better pay attention real carefully. You ready? There's your relative minimum, there's your relative maximum, and there's a relative minimum. Tough, isn't it? All right. So I've got a relative minimum. I've got two of them. I've got one at -1, and I've got one at 1. Okay? Everybody see that? Now, notice we found our critical numbers, and it says, and classify each critical point. Okay, so I'm getting my critical point. So a point contains an x coordinate and a y coordinate. Okay, so if I've got the x coordinates -1 and 1 for my relative minimum, we got -1 and 1. What do I need? I need the y coordinates, right? So how in the world do I find the y coordinates? Well, you take the x coordinates and plug them into the original function, right? F of x is the same thing as y. You could say f of x equals, or you could say y equals. So if I need, I mean, think about it. You did this all in algebra and everything. If you have an x coordinate, how you get the y coordinate? You plug it into the function. And so now I would have, I guess I'll come down here and do it. I've got f of -1 is equal to 2 times -1 squared. Oh, not -1 squared. -1 to the 4th minus 4 times -1 squared plus 3. And so that's going to be 2 minus 4 plus 3. That's -2. Was that 1? And then f of 1 is equal to 2 times 1 to the 4th minus 4 times 1 squared plus 3, which is 2 minus 4 plus 3. That's -2 plus 3 is 1. So there's my relative minimum points. Okay, my relative minimum. All right. Now, what do we need to find? Well, we've got the relative maximum, right? Our relative maximum is at 0. And of course, if you plug 0 in here, you get 3. So that would be 0, 0, and so you would end up with 3. And so there's your critical points right there. Okay. All right, so let's keep going. Sketch the graph. Okay. So sketch the graph. Now, what I wanted to show you here real quick. This is going to help us when we sketch the graphs. So you could have a graph like, well, let's do this. Well, copy this down if you're taking notes, because I'm going to erase it because I'm going to need the room. Okay, you could have something like this. See how it's increasing and decreasing? This is f prime is positive, and this would be f prime is negative, right? It's increasing and then decreasing. Remember how we determined that where the function was increasing and decreasing, and it's increasing where the derivative is positive, decreasing where the derivative is negative. Okay, and you can see you have here's your maximum point there, and then you have this, right, like this. It's decreasing, it's increasing, so you can see f prime is negative, and here f prime is positive. Okay. Now, what if we have something like this? It's like this. See, it's increasing, right? So f prime is positive, and here we've got f prime is positive. So you remember that problem? Where was it? Here, see how it's decreasing. Okay, that's like what I just drew down there, except of course I drew it increasing instead of decreasing, but it's the same concept. What happens there? See, if it's decreasing, you've got your relative maximum point, and if it's decreasing then increasing, you got your relative minimum. But if it's steadily increasing, what happens at that point right there is it kind of twists like this a little bit. And this right here, we'll look at this in even more detail when we talk about concavity. See, concave down, how it's kind of facing down, and this would be concave up, like it's facing up. That has to do with the second derivative, and that's in the next video. We'll get into that in more detail. All right, but just so you know, this will help us draw the graphs. Okay. All right, so let's get rid of all this junk right here, and let's work these problems. Sketch the graph. So in order to sketch the graph, you want to find your critical numbers. You want to determine where the graph is increasing and decreasing, and you want to find your relative maximum and minimum points. Okay. All right, so basically what we've been doing so far is here's how you find out where it's increasing and decreasing. This is how you find the critical numbers. This is how you find the relative max and min. And now what we're doing is we're taking all that and putting it together to graph the function. See? We practiced everything, and now we're putting it together. All right. So take the derivative. That's 4x cubed plus 24x squared plus 36x. And so now I got 4x cubed plus 12x squared plus 36. Oh, wait a minute. What am I doing? Plus 24x squared plus 36x, and we're going to set that equal to 0. So I'm going to factor out a 4x, so that's x squared plus 6x plus, what is that, 9 equals 0. And so I've got 4x times x plus 3 times x plus 3 equals 0. Okay. All right, so let's look and see what we got here. So I've got 4x equals 0 or x plus 3 equals 0. I just need one of them. So x equals 0 or x equal negative 3. All right, so let's plot this on the number line. So I've got negative 3 and 0. All right, so that's going to break this up. So I'm going to choose x equal negative 4, x equal negative 1, and x equal 1. Like I said, those numbers, doesn't matter which ones you choose as long as you choose one from each region. That's the main thing. So I've got f prime of negative 4. Now you can go back and plug it into this one, but it's easier when you plug it into this one. So that would be negative out here, right? This would be negative 1. This would be negative 1. So I got a negative times a negative is a positive times a negative is negative. That's less than 0. So that's decreasing. So now let's try f prime of negative 1. So that would be negative out here, positive here, positive here. So negative times a positive is negative, times a positive is negative. So that's less than 0. Oh, look at there. We got 2 that's decreasing, 2 in a row that's decreasing. And then we've got f of 1. So if I plug the 1 in, that's a positive times a positive times a positive, which is a positive. So that's increasing. And so we've got this thing is decreasing. Okay. It's decreasing from negative infinity to negative 3 and negative 3 to 0, and it's increasing from 0 to infinity. All right, and then you can see here I only have a relative minimum. There's no relative maximum in this one. So I have a relative minimum at 0. And then what do? I take the 0, I find f of 0. So what does this mean, f of 0? That means I take the 0 and plug it back into the original function. And you can see when we plug the 0 in, we get negative 8. All right. And so guess what? Now we are ready. We are ready to graph this thing. All right. So I've got the value 0, negative 8. That's my relative minimum. Okay, that's my relative minimum. All right. Now, also, what I would want to do here is I've got another point. Negative 3 is a critical number. It would be a critical point. It's not changing. There's no relative max or min there, but it would be nice to know what the coordinates are. So if I look at this, I've got the point negative 3, and then I do f of negative 3. So if I plug negative 3 into here, I believe I get 19 as an answer. Okay. All right, so I've got the point negative 3. We'll call that about right in here, and that would be, we'll call that 19. And so let me do this. Since that's 19, let's call that negative 8 right there. This is going to be the point negative 3, 19. This is going to be the point 0, negative 8. So what is this thing doing? See how it's decreasing from where x is negative infinity all the way up to negative 3 and to 0. It's decreasing. All right, so remember what we talked about. We got the negative negative. So this thing is decreasing. It's coming down like this. And then here it kind of, see how it kind of wiggles through here, it changes like that. Remember, that's what that meant, what I drew on there earlier. And then once it gets to 0, it starts increasing again. And so it's coming let me see if I can draw that a little better. It's coming through like this, and then once it gets here, it starts increasing again. And so, and also we can see this is our relative minimum, so you know it comes down and turns back up. And so there's the graph of it. All right, it's not too bad. All right, let's look at this one. Let's graph this one. So I've got f prime of x is equal to 6x squared plus 12x plus 6. All right, so we're going to take 6x squared plus 12x plus 6 equals 0. I can factor a 6 out. That's x squared plus 2x plus 1 equals 0. So that's 6 times x plus 1 times x plus 1 equals 0. So x plus 1 equals 0 means x equal -1. I don't need to set both of them equal to 0. So we've got this, we've got -1. So I'm going to choose x equal -2 and x equal, we'll choose 0. So I've got f prime of -2. So I can plug the -2 into here. So that's -1 times -1 is 1 times 6 is 6. It's positive. So that's increasing. And then if I do f prime of 0, plug the 0 in, that's a positive times a positive times a positive is positive. So that's increasing. Okay. So we can say that this thing is increasing from -infinity to -1 and -1 to infinity. And then relative max, none. Relative minimum, none. There's no relative max or min. But we do have a critical number at -1, so I would like to know what that thing equals at -1. So I'll do f of -1 is equal to, so we're going to take the -1, plug it back into the original function. And I get 3 as an answer. Okay, I paused and punched it into my calculator. I don't have the answers to these problems here. We're just working them. All right, so let's see what we've got here on the graph. All right, so I've got -1, 3, which we'll say is about right there. All right, so, we got that 1 point. If you want to, you could get another point. And, a point that would be easy to get is f of 0. I mean, it's not going to do anything at 0, but it gives us another point to look at. So if we plug 0 into here, we're going to get 5 as an answer. So we would have the point 0, 5. So we know it's going to go across the y-axis there. But just notice from -infinity to -1, -1 to infinity, this thing's increasing. So this thing's going to come like this. And then once it gets here, it's going to kind of turn up like that. So it goes up, and then there's that point there where, see, it's positive, so it's going to have that little twist in it. And so that would be your graph there. So that's not too bad. All right, this is the last graphing problem, and then we got us a good old word problem to work. And then that'll be it. So don't leave. Watch the rest of the video. All right. So we've got f prime of x is equal to 15x to the 4th minus 15x squared. So 15x to the 4th minus 15x squared equals 0. I'll factor out a 15x squared. And so I would be left with, what, x squared minus 1 equals 0. So 15x squared equals 0. That would give me x equals 0. X squared minus 1 equals 0 is x squared equals 1. X equals plus or minus the square root of 1 is just 1. And so now we've got -1, 0, 1. So I've got x equal -2, x equal -1/2, x equal 1/2, and x equal 2. So I'm going to do f prime of -2. I'm going to do f prime of -1/2. I'm going to do f prime of 1/2 and f prime of 2. All right, so just real quick, because we've done several of these, let's plug the -2 in. That's positive, positive, that's positive. Plug the -1/2 in. I mean, this out here is always positive, so this is going to be a negative in here, so that's going to be less than 0, so that's decreasing. Same thing here, less than 0, that's decreasing. Plug the 2 in, that's going to be greater than 0, so that's increasing. So we've got decreasing from -1 to 0 and 0 to 1, and we've got increasing from -infinity to -1 and 1 to infinity. And then let's see what we've got here. Look at this. We've got a relative max and we have a relative minimum. So we have a relative minimum at 1, where x is 1. And so then we're going to do f of 1. So if we plug a 1 into here, that's going to be -2. So is that 2? And then we have a relative max at -1. So let's see. What is that? That's a -3. +5 is 2. Would that be 6? I'll have to double check myself. I just did that real quick in my head. I'll have to double check. Let me see. Okay, so that's all right. All right, so now I think we're ready to draw our graph here. All right, so we've got -1, 6. We'll say that's about right there. We've got 1, 2, which we'll say that's about right there. And that's really about it. I mean, if you wanted to, something easy to do, f of 0 is equal to 4 if we plug 0 in. So that would be, you know, maybe about right in there. Well, I guess it would be what? It would be exactly halfway in between those two, wouldn't it? So let's see. Here I've got the point -1, 6. Here I've got the point 1, 2. And here I've got the point 0, 4. So this thing's decreasing, right? No. From -infinity to -1, it's increasing. So it's increasing right here, and then it's going to turn around and look at this from -1. See, this is -1 to 1. See, it's decreasing. So it's coming down like this, but then it's going to have that little twist in it. Okay, let's see. Maybe not like that. Let's see. It's going to look something like this. Like this, and then here, and then it's going to come back up. So this one's a little more, might be a little more difficult to see. I mean, it's coming down, so it's going to go here. It's going to kind of curve this way. I'm exaggerating it, and then it's going to come back this way and kind of curve. Okay, now this right here, you know, if that confuses you, this how it's curving like that, that's where the next video is going to come in, the concavity of it. We're going to determine, okay, from here to here, it's concave up, it's concave down. We got a method to determine that with the second derivative, but that's the graph of it. Okay, all right. So now let's do the word problem. All right, the revenue derived from the sale of a new kind of skateboard T weeks after its introduction is given by this. That's the revenue in millions of dollars. And T is between 0 and 63. When does maximum revenue occur? And what is the maximum revenue? So when does the maximum revenue occur? Well, that's when we have a maximum for T. All right. And what is the maximum revenue? Well, whenever we find that T value, we plug it back in, and that'll give us our answer. So let's go ahead. We need to find the first derivative. So we got to do the quotient rule. So the derivative is the derivative of the numerator, which is 63 minus 2t. So it's the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator. All over the denominator squared. All right. All right, so here comes the fun part, simplifying this thing. So I'm going to get, oh goodness, I got to multiply all this out. So that's going to be 63t squared plus, and I have no idea what 63 times 63 is. That is 3969. I hope these reduce quite a bit. So that times that. Now I've got, what, negative 2t cubed. Yep. Minus, let's see, 63 times 2, 126t, minus, and then that's going to be minus, that's going to be 126t squared plus 2t cubed, and that's going to be t squared plus 63 squared. And so let's see what happens here. Well, these t cubes cancel out. And so now we've got, let's see, 63 minus 126. 63 minus 126. That's going to be negative 63t squared minus 126t plus 3969 over t squared plus 63 squared. All right, boy, wasn't that fun. Now, let me see. This is going to be, let's see if we can factor out a negative 63. So that's going to be t squared plus 2t minus, now let's see, 3969 divided by 63 is 63. There you go. So that's going to be t squared plus 63 squared. All right, so now, well, what do we got to do? We got to determine if it's a relative max or min. So we've got to set the, so remember, this is your first derivative here. So we set the first derivative equal to 0 and solve. So, well, the denominator is never going to be 0. Because, see, it's t squared plus 63. That'll never be 0. But now the numerator, I can take the numerator, t squared plus 2t minus 63 equals 0. I don't need to set that equal to 0. That's just a number. So now we will factor, and that's going to be t, that's going to be plus 9 minus 7. So t plus 9 equals 0, or t minus 7 equals 0. So t equals negative 9, or t equals 7. So we need to plot these on the number line. I'm going to plot the 7 on the number line, and that's it. I'm not plotting the negative 9. And why is that? Because up here it tells me that t is between 0 and 63. So I know that I'm between 0 and 63. -9 is out here. It falls outside that interval. So here I'm going to choose t equals 1, and how about t equals 8? And so what we're going to do here is we've got to plug that into the derivative here. Now, once again, remember how I told you we got what? T plus 9, t minus 9, t minus 7. Remember how I told you you can use the factored form. It's easier to plug in. So this out here is always negative. The denominator is always positive. So plug into here. If I plug the 1 in, that's a positive, that's a negative. So a negative and a negative is a positive, and that's a positive, so that's increasing. And then if I plug the 8 in, that's positive, that's positive, that's positive, but this is a negative out here, so that'll make it negative. And so you can see I have a maximum when t equals 7. And let's see. Does it say? Yeah, 7 weeks. This is in t is 7 weeks. So that's 7 weeks. That answers the first question. And then r prime, not r prime, but let's write down the original function. That's 63 t minus t squared over t squared plus 63. So we'll do r of 7 is equal to 63 times 7 minus 7 squared over 7 squared plus 63. And you'd probably have to punch that in your calculator, and you would get 3.5, and that would be $1 million. All right. And that's your answer. And that's the last problem. That's the end of the video. I hope you enjoyed this. I hope it helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.